Good afternoon. My name is Dr. Alex Weber-Kamen, and I'm going to be talking about the review exercise that we completed recently for a class in Computer-Aided Design, Engineering 151. So as part of the Engineering 151 course for spring 2026, I assigned, as part of the review session at the beginning of one of the classes, we discussed an exercise where the students were assigned to generate a 10 by 10 by 10 millimeter cube with a 5 by 5 by 10 millimeter hole through the center of it. So the assignment process is draw the shape in SOLIDWORKS as a SLD PRT file. Create a drawing containing the three standard views. Those are top, front, and right, as well as an isometric view. And per the standards of the class, include your name, the assignment name, and the date. Generate a PDF of the total drawing and save and submit the PDF as well as a zip file or 7Z archive containing all of the SOLIDWORKS files created as part of this process, therefore an SLDPRT of the part and SLDDRW of the drawing, and save those two files, the PDF and the archive, to Canvas in the example submission file, or correction, the assignment file. And if you're done early, we'll discuss talking about different ways to create this part. So this being SOLIDWORKS, there are numerous different correct ways to make the same exact part. It's just there are some that might be more efficient than others. So we'll skip into SOLIDWORKS now. And as you can see, I've got the part already drawn from a previous take, so we'll ignore that. So starting afresh, new file, part, okay. Computer's a little bit delayed right now. So what we're going to do is go to the context menu at the top for Sketch, Sketch, Front Plane. And what I'm going to do for starters is grab a center rectangle and place it right on my origin. And you can see when I hold Shift, it forces the rectangle to become a square. Therefore, the sides are the same dimension. If I remove the Shift or not select it, it moves and I can select the two sides as separate sizes. So I'm going to hold Shift and force it to be a square, and then come up here to the Smart Dimension tool and select one of the sides and set it as 10 millimeters. And then I'm going to place another center rectangle centered on my origin. And you can see if I trace these angled bits connecting the center to the corners, it's going to force the other square inside it to also be a square. And right now I am not holding down Shift. So we're going to select another smart dimension. We're going to specify the size of that inner square as 5 millimeters. And we're going to go back to our drawing and show this dimension, the 2.5 thickness of the wall, is not necessary for us to add as a smart dimension at this step, because right now we have two squares that are equally or coincident on the origin, where that center point is on that 0, 0 mark. And we've given the size of the wall as 5 and 10 millimeters respectively. And we've told the computer with the use of our corner and our correction center rectangle tool that we want the horizontal lines to remain horizontal and the verticals to remain vertical. Therefore, it's not at an angle other than 0 and 90 degrees. So if we select a smart dimension tool and try to drop it here, you can see that that measurement right now is 2.5 millimeters, but if I actually apply it, it's going to show an error that make the dimension driven is indicating that we've got a redundant value here. So we're going to click cancel because we don't need that measurement in there. I'm going to say OK. And we're going to leave our sketch. So top right button or top left exit sketch. And then we're going to switch to our features context bar where we've got an extruded boss base. And you can see it's now extruding the box as we intended. So we're going from the sketch plane, we're going blind outward because we don't, in this case, care about which direction it's extruding, and we're going 10 millimeters from based on the original drawing. And then as far as the sketch contours, I'm going to draw your attention to that, where right now it's selected the O itself, or the actual shape, but it could have just as easily selected the inner part of the shape, or it could have selected the outer portion, so it's the entire cube. But SolidWorks will make an effort to try and make a guess of what you're intending and not always get it correct. So we're going to make sure that when we check our contour, we look at the preview to see this is what we expect. So we're going to say OK. And say, yay, we found our cube. So we're going to save it, and we're going to name it Review Problem Chapter 1, and in this case B, because this is our second big take. And we're going to go up to File, and then we can either choose to make drawing from part, or we can create a new drawing. So we're going to try make drawing from part. And we're not going to use the ANSI drawings for now. So each of these includes various different features that are very useful in the actual design office, where you can see it comes in with a pre-generated border as well as a title block. But for now, we're going to go with just a blank piece of paper that is 11 by 8.5 inches. I'm going to say OK. On the right, you can see that it popped up with a initial drawing view that we could just easily drag these in from here onto our sheet, but we're going to do something a little bit different. And this appears only in the context of make drawing from part. So for starters, on the bottom right, we're going to double check our units. So right now, my drawing is in inch pound second units, so we're going to switch to millimeter gram seconds. And that's just with this little box at the bottom. Or we can go to the top and go to options, start typing in unit system, and switch from inch pound second to mmgs. So we now have a blank sheet of drawing paper, and we're going to go to drawing in the context menu, model view, and then you can see right now SolidWorks knows that my review problem chapter 1B is open in the background. So I could just select this and go to next, or I can select browse and open any of my various SolidWorks parts such as SLDPRTs. But for now, we're just going to go with the one that we just drew and go to next. And we're going to select orientation, create multiple views, top, front, right, isometric, and deselect trimetric. So those are going to be the 4 standard views that we're going to look at for this class as the standard. We're going to change our display style from hidden lines removed to hidden lines visible. And if, when we're looking at these preview images, if the scale looks like it's something that is a bit too big or too small, we can change the scale here. So if we want to say, okay, we're going to make it slightly different sized, could do 4:1, or we could do, say, 6:1. Oops. So what you can see is the size is going to be 1 unit in the part is equal to 6 units on the page. We want to make sure our dimension type is true, because when we start looking at the isometric views, if we wanted to put a dimension on those, it might not show as a true dimension, like the actual dimension on the part. So this brings us our square. So top, front, right, and isometric views. And then we're going to go to annotation, note, and I'm going to drop a little box down here, including my name, the assignment name, and the date. Swear I do know how to spell. And then we're going to select all that, and then you can see under formatting, we've got various different options that we can select, such as font size, if we want it to be a different color, bold, etc. And we're going to say OK. I'm going to move that a little bit over. And then we're going to save this as an SLDDRW, noting that it's a SolidWorks drawing. Say OK. And then we're going to go to print to PDF. And we're only printing the current page because we only have one page. I'm going to say OK. And we're going to name this review problem chapter 1b.pdf. We're going to say save. It's going to take a moment to generate. And then we're going to switch to our folder that we've got our example problems in. So review chapter 1. And you can see we now have 3 SolidWorks files that were generated, or I should say 1 PDF and 2 SolidWorks files. So we're going to take our 2 SolidWorks files, the SolidWorks drawing and SolidWorks part, right click, and we're going to put them into 7-zip, add to archive. You can see we've got a nice name up at the top that we're going to review problem chapter 1b.7z. If you wanted a different archive format, you could switch from 7z to zip, WIM, tar, etc. So in our case, we just wanted a 7z. We're going to say OK. Oh, and we get a regular error that we say, OK, SolidWorks doesn't allow 7z to have access to the files that we have open. So we're going to say close. And then we're going to go back to SolidWorks and close that. Then right click on the 2 files that we want to put into 7z, add to archive. I'm adding it back to review problem chapter 1b. And you can see our archive now is 92 kilobytes. And then what we're going to do is go back to our Canvas page on the website under Assignments, Review Exercise, Chapter 1. And you can see I'm in Student View right now. I've got the previous take submission. I'm going to go to New Attempt, drag a file here to upload, and I'm going to go back to my Explorer. You can see I've got my 7-zip archive containing the 2 files and my PDF of the drawing that gets dragged in. And I'm going to submit assignment. And why I'm requesting the PDF and the 7-zip is so that I can look at the assignment and be able to see, okay, test student, that's me. The PDF, I can see a preview of what the PDF is on the website, and we've got the submission that I just completed. And if I wanted to, I can download the 7-zip file and be able to open up the various different SolidWorks parts and drawing file that were included in this. So with our extra time, what we're going to do is go back to SolidWorks and discuss different ways that we can look at making this part, because that's frequently illuminating as far as different ways to go about this. So one thing that we can look at when we look at the original problem statement, this is a cube. All four sides are the same. The inner part is also a square before it's projected. So what would happen if we did, instead of a predefined center rectangle, we decided to use lines to generate this? So I'm in Sketch, I'm creating a line, I'm selecting the front plane, line, and then on my options here, I'm going to select for construction, infinite length, and then I'm going to give it a horizontal. And what I'm doing here is setting up some lines that I can use as mirror points, or I can see that the original square is symmetric vertically and horizontally. So what I'm doing is setting up those symmetric lines that I can use now. And then I'm going to come in and select a point on that line and make sure it goes vertically and make sure it goes horizontally. But you can see I didn't care too much about making sure the dimensions were correct, yet at least. And then I'm going to select another line and select it down on the bottom. And again, doing a kind of L shape. And what I'm going to do is select the Smart Dimension tool to dimension this. And you'll remember when we were looking at this, we've divided the square into essentially quadrants. So we're going to divide each of the dimensions by 2. So the middle square is 5 millimeters divided by 2 is 2.5. The top part is 10 divided by 2 is 5. And then where we can get creative is we've got this line selected and this line selected, and we can use our add relations box to make them equal. So you can see this line here already was set as horizontal. We know this end is going to stay on this vertical line because it's was set as a snap for us. And then that means this line is going to go upward only because we said this line is equal to this line. And then we're going to do the same thing on the other side. If I selected this one, hold Shift, left click the other line. Oops. And you can see on the left here, I accidentally selected point 12. So I have line 5, line 6, and then point 12. And we're going to delete that section, that point. We're going to say, okay, these two are now equal. Say okay. So now we have 1/4 of a square. I'm going to select that. Mirror entities, noting that my copy is on, and then mirror about. And you can see my preview now. Blue is what exists, yellow is our preview. We're going to say okay. That's kind of an unusual behavior. But what just occurred is when we did this mirror across, this line became the same line essentially. So we said this section is 5 millimeters, the other section is another 5 millimeters. So our vertical axis became 10. Basically, this line shifted up, which is an important thing to consider. So we're going to delete that. We're going to go to the other side, do the same thing. And we don't have an existing line there. So what we're going to do then is use our smart dimension. Go to the side here and say that should be 5. And then likewise, go to this line here, Control Z, because whenever those two lines reduced, it made it overlap. I'm going to delete that equal line. I'm going to set that as 2.5 again. Change this smart dimension back to 5. And then we're going to select all of this, mirror entities, mirror about, horizontal axis. And we now have the same square within a square that we were looking at before. So that would be option number 2. Going to go ahead and delete that. Going to try and delete all of that. So we're going to go into option number 3, which is going to be a little bit strange. So bear with me for a moment. So prior to now, I had been drawing on the front plane. In this assignment, we're not making a specification on what the different planes the end product should be in. And in general, it's not going to matter until you start working with coworkers or having parts that you're working together with in, say, an assembly. So what I'm going to do is switch to the front plane, and then I'm going to draw a center rectangle on the 0, 0 mark, the origin. And holding Shift, force it to be a square, mention, and I'm going to force that to be 10 millimeters as a square. And then we're going to go up to the center rectangle and switch to corner rectangle. And I'm going to drop the first point of our corner in the top left corner, and then the second point on our right vertical line from the original rectangle. And then while I've still got corner to corner rectangle selected, I'm going to select bottom left and go to the right vertical line. And you'll notice that I was not really caring too much about the dimension that I just placed in there. So the horizontal lines are going to remain horizontal because that's how we selected it as a relation when we created the rectangle initially. It's probably pre-built into the rectangle tool for you, and if not, you can modify it in the options. And the bottom left is going to be a fixed point. It's coincident for the corner to corner rectangle with the original center rectangle. So I'm going to select this line and this line to do a smart dimension about and say that is going to be 2.5 millimeters. And then this line to this line, I'm going to say is 5 millimeters. And then I am not going to do a dimension from this upper line to the very topmost line because that would be redundant. We've already said that this outer dimension for the square is 10 millimeters. So 10 millimeters minus 5 minus 2.5 is 2.5. But if I put that as a dimension in here, that would be redundant, and it would lead to the error state that was over defining our rectangles. So we now have sketch number 2 because we're reusing our part drawing from before. And we're going to switch to the context menu for features. So going to extruded boss space. And we're going to go from sketch plane, blind, 2.5 millimeters, and then selected contours. If I can get it to work, which it looks like it won't cooperate again, we're going to select the 3 contours or interior sections of our sketch. So we now have a full rectangle that is 10 millimeters by 10 millimeters. That is the accumulation of the 3 sketch regions. I'm going to say OK. And then we're going to go back to extruded boss space. In our picture-in-picture feature manager, we're going to extend Boss Extrude 1 and go to Sketch 2, the one that we drew a moment ago. And we're going to select contours, the outer rectangles, and we're going to go from Surface Face Plane, which is going to be a new use of the tool for us. Select this face, and you can see instead of coming from the sketch plane, the flat plane down at the bottom, and going up, we've now set the new plane that we're going from as this surface here, the green surface, and each of these is extending up 2.5 millimeters. So we're going to set that as 5 millimeters. And then a common mistake that I've seen a lot of people make is deselecting this merge result. So if that was not selected, then these three features would not be the same body at the end of it and lead to some fun geometry issues. So we're going to say OK, and then extrude boss base again. We're going to reselect sketch 2. And instead of from sketch plane, we're going to do surface face plane again. And instead of it being 5 millimeters, it's going to be 2.5 millimeters. And selected contours, again, we're selecting the various different 3 regions. And our new surface plane that we're extending from can be either of the rectangles that are the new small faces up here. Oops. And that's now option number 3. So we can select our little rotating tool, be able to peek in, nice, even, and then follow the same procedures of the drawing creation that we talked about before. So these are 3 different options that we can look at as far as this same shape that, for being a very simple shape, has a lot of different options that you can come up with to create it. So I hope this helps. See you guys in class next time.